We're going to take a look at worksheet number 2, specifically questions 7 and 8 of the homework that we had last night. Number 7 says a 1.5 kilogram rock falls from rest from the top of a 10-meter high building, strikes the ground below. What's the impulse experienced by the rock during its fall? This is not completely unlike a question that we did, a couple questions that we did earlier actually, where we wanted to find the momentum of an object after it fell. In both cases, we have to find out how fast it's moving after it's fallen. So let's write down some givens here and then let's go to work doing that. Let's say the mass of this rock is 1.50 kilograms. Tell me something else. Tell me something else besides the mass. Okay? Sorry? Okay, so I see 10 meters, the distance it's fallen. What do you want to call that, 10 meters? Displacement, yeah, is that right? Displacement's 10 meters? Almost? What are we going to do to this? Why did I make it negative 10? Because it's falling, it ends up below where it started, right? What else we got? What else we got? There is something else if we read between the lines here. Yeah, JC? Yeah, acceleration is neg 9.81. We want to make sure that this sign is consistent with this sign, right? Because they're both downward. There is one more thing that I can see if I read between the lines, Parker. Good. So we're going to say VI is equal to 0 meters per second, right? We want to find the impulse during its fall. So we're going to say, look, we could say impulse is equal to F times T. That's valid, right? I'm going to try that. Go ahead. It'll work. But I would suggest to you that's not the easiest way to do it. To do this, you're going to have to say F is equal to, 1.5 times 9.81. Force of gravity pulling down on it. But then you don't know what T is either. I think you're going to use this one. VFT minus 1/2 AT squared. Solve for T. That's kind of ugly. It'll work though, right? Anybody do that? No? Okay, that's fine, because that's not the way I do it either. Here's the way I would have done it, or the way I did do it. Is that valid? F times T, M times delta V, same thing, right? I know what the mass is. It's 1.5. And delta V, well, VF squared is equal to VI squared plus 2AD. VF ends up being equal to 14.0071. How many people did it that way? Yeah. Anybody do EI equals EF, like 1F mgh equals 1F mv squared? It's fine too. You remember that from physics 20? Okay, that would be fine as well. You could do 14 as well. So my final speed is 14.0071 meters per second. What's my final velocity? If the speed is 14, the velocity as it goes downward is negative 14. Subtract the initial, which is 0. That works out to be an impulse of negative 21.0107 Newton seconds, or around that to 3 digits, negative 21.0 Newton seconds. Okay, interesting here. I want to ask you about the sign here. We got a negative value for this. That means something. It's like negative and positive are never random. It means something. What does the negative mean here? Remember we talked about direction and impulse yesterday, signs and impulse? Yeah? JC?
Speeding up, going down.
Good. You gain momentum in the negative direction. What would the other way to get a negative impulse be? Speeding up or increasing momentum in the negative direction, like we have here, or it could be slowing down in the positive direction. If this rock had been rising into the air and slowing down because it's rising, that would have been a negative impulse as well, because it would have been slowing down in the upward direction. Okay, does that make sense? Okay, good. Number 8 Similar, except this time we're looking for the force of the ground acting on the rock as it stops. So the force of the ground stopping it. This time, like, think about what's going on here. In question 7, we're analyzing the fall. In question 8, we're analyzing the collision with the ground. In question 7, VI was 0 and VF was 14. In question 8, VI is negative 14.0071 and VF is 0. Make sense? Because during the collision with the ground, it's starting at 14, and after the collision with the ground is done, it's stopped. VF is 0. Oh, you know what? We also have the impulse here in question number 8. What is it? If you gained 21 Newton seconds of momentum on the way down, how much did you lose when you stopped? Your impulse was negative 21 as you fell. What's your impulse as the ball stops or as the rock stops? Tim? No. Well, when it's stopped, the momentum is 0, yes. But the impulse experienced as it stops is not 0. What is it? 21. Negative 21? Negative 21? Yes. Good. Positive 21. How come? How come the impulse, we know why the impulse as it fell was negative because you gained momentum as it went downward. Why is it positive when the object stops? Negative when you gain momentum in the negative direction, positive when you lose momentum in the positive direction. When this rock stops, it loses momentum, right? Okay, what would I do here? Listen, I want to find force. I think I'm probably going to use delta P is equal to F times T. That's the first part of that equation. Rearrange it. F is equal to delta P over to delta T. I just found delta P. It's 21.0107 and divide it by 0.350. Gives me a force of 60 newtons. Positive? Yeah, it should be positive. Rock is falling downward. How do you stop it? By applying a force upward to stop it. And upward force is a positive value, right? Yeah, that makes sense? Yeah. Question?
Yeah. You know how it's like F equals M times A?
Yeah.
I have both and like I'm just finding the F.
Oh, do you have A?
Like it's going down, so it's going to go negative.
Are you talking about question 7 or question 8? Okay. Do you have A for question 8? 9.81? Who thinks it's 9.81? Question 7, it's 9.81. Question, because it's falling under the influence of gravity. But question number 8, it's not 9.81 at all. It's 9.81 if gravity is the only thing influencing it. Gravity doesn't cause this thing to stop. What causes this rock to stop? The ground. So there's a force of the ground pushing up in addition to gravity pulling down. So I don't know what the acceleration is. It would be pretty big acceleration because it stops pretty quick, right? But it wouldn't be 9.81. Okay, make sense? 9.81 if it's only gravity acting on it, as was the case in question 7. But when it's stopping, there's the ground as well. Okay?